We will start with anomalous behavior of oxygen. Oxygen has got some unique properties which differentiates it from remaining members of the family. The first property is small size. Because of very small size, it has got some peculiar characteristics. Second is high electronegativity. Because of these two reasons, small size and high electronegativity, oxygen atom is capable of forming strong hydrogen bond like in water. Same thing cannot be done by sulfur because sulfur is large in size and it is less electronegative. Oxygen has high ionization enthalpy. Because of small size, it takes lot of energy to remove the electrons of oxygen atom. Oxygen does not have d orbitals and hence it cannot make many bonds. If you have many d orbitals, or if you have d orbitals, you can make more bonds, but oxygen just has s and p orbitals, therefore it can make maximum number of covalent bonds only 4 at the most, but in practical situation you will see it makes only 3 covalent bonds. The meaning of the word covalency is number of covalent bonds. All the elements of this family, group 16, react with hydrogen to form hydrides. When somebody reacts with oxygen, the compound is called hydrides. The formula is H2E. These are the formulae written in front of you. They have two typical characteristics. Number 1, acidity. Number 2, reducing character. Acidity is the tendency of any compound to release protons, and reducing character is the tendency of any compound to release hydrogen atoms. If you talk about the hydrides of this family, as we start going down the group, the size of the central atom goes on increasing and the tendency to make bonds with the tiny hydrogen atoms goes on decreasing, because the central atom is very big and hydrogen is very small. Hence, as you start going down, the bond length will go on increasing and the bond strength will go on decreasing, and the tendency to release the hydrogen atom as well as hydrogen plus ions will go on increasing. So, this is written like this: low bond dissociation enthalpy. So, due to this factor of low bond dissociation enthalpy, the acidity will go on increasing down the group and the reducing character will also go on increasing down the group. All the family members react with oxygen to form compounds of two formulae. One is like EO2, example SO2, and the second formula is EO3, example is SO3. This is not difficult to remember. Both of these formulae are going to depict acidic character, which means that when we add them in water, we get acids. The symbol E stands for these elements. All of them react with halogens to form compounds of these three formulae: EX6, EX4 and EX2, and the hybridizations will be sp3d2, sp3d and sp3. I am sure you know of everything about hybridization. You have already done that in class 11th. I will give you one example, but let us take the example of SF4. Now, in SF4, sulfur atom has got 6 valence electrons, please remember, because it belongs to group 16. So, I am drawing those 2 electrons here, and the remaining 4 electrons of sulfur are used in making single bonds with fluorine atoms. Okay, so total electrons I have accounted for is 6, these 2 and 4 of the bond pairs. Now, how many pairs of electrons you have? If you count, you have 4 bond pairs, that means 4 sigma bonds, and you have 1 lone pair. Total number of electron pairs is 5. Hence, 5 means sp3d, 5 means sp3d, 6 means sp3d2, 4 means sp3. Here, stability order, fluorides are going to be always the most stable than chlorides, then bromides, then iodides. because fluorine makes very strong and short bonds, and also when fluorine makes a bond with any element, it releases lots of bond enthalpy, or it releases lots of lattice enthalpy. So, due to higher lattice enthalpy or bond enthalpy, the fluorides will be more stable than chlorides, bromides and iodides. Oxygen molecule is chemically known as dioxygen because it is made up of 2 oxygen atoms. Preparation, we will see 4 important methods. The first method is by decomposition. Every time you are going to decompose, only see here, decomposition. When you decompose such compounds which contain lots of oxygen, like potassium chlorate, which is red colored compound, potassium chlorate is heated in presence of catalyst manganese dioxide to give you potassium chloride plus oxygen gas. Potassium permanganate is also heated to give you potassium manganate, manganese dioxide and oxygen. Color, everyone is aware of violet color, green color, black color, MnO2. Try to remember these reactions. Thermal decomposition means using heat you have to break down the compound of those metals which are low in electrochemical series, which means they are less reactive, like silver, oxygen, lead, etc., etc. So, there in the book you have been given these reactions, so we have to study these. Silver oxide, lead oxide, mercury oxide, if you heat them, automatically you will get the compound, the element and the oxygen, or some compound with oxygen or the element and oxygen here. Okay, so please learn this. The next is your decomposition of hydrogen peroxide, which is called as disproportionation of hydrogen peroxide. Disproportionation means the self oxidation and self reduction of oxygen atom here. Commercially, every gas can be prepared, every gas which is elemental like oxygen, nitrogen, neon, argon and all that, they can be prepared by fractional distillation of air. By the difference in their boiling points, they can be separated. Second is electrolysis of water. In electrolysis, you are going to take the substance, whatever electrolyte is there in a tank, which is known as electrolytic tank. So, we will take H2O mixed with some acid or base, because water is a poor conductor of electricity, and we are going to pass direct current through it because we are going to carry out electrolysis. And during electrolysis, at anode and cathode, cathode is negative, anode is positive, we will see that the oxygen gets liberated at cathode and the oxygen gets liberated at anode. Physical properties, it is a colorless, odorless, tasteless gas, slightly soluble in water, has got 3 stable isotopes, 16, 17, 18 is the atomic mass number. It is a paramagnetic gas, which means that it gets attracted towards external magnetic field. Oxygen gas has got 2 unpaired electron in its pi star antibonding molecular orbital, and hence it is going to be paramagnetic in nature. Chemical properties of oxygen is so powerful oxidizing agent that it can react with metals, non-metals and also compounds. Okay, it can react with metals also, non-metals also, compounds also. These reactions are very simple ones. It can react with metals like sodium to form sodium oxide, calcium to form calcium oxide, aluminium to form aluminum oxide, which is also called as alumina or bauxite. It can react with iron to form iron oxide, which is also called as hematite. It can also react with gases like nitrogen to form NO, nitric oxide, which is actually a pollutant and it can cause depletion of ozone layer. Similarly, it can react with phosphorus to form P4O10, that is phosphorus pentoxide, which is a very good dehydrating agent in organic chemistry. You can use this. Reaction with compounds, these 3 reactions are important for your exam. The first reaction is a part of contact process, which is used for manufacture of sulfuric acid industrially. So, in contact process, we are going to use this catalyst vanadium pentoxide and heat SO2 with oxygen and get SO3 gas. So, oxygen basically is going to act as oxidizing agent in all these reactions. And finally, we have this HCl, it oxidizes HCl also to give you chlorine gas. So, oxygen is so powerful that it can oxidize chloride, bromide and iodide to chlorine, bromine and iodine. Just remember this point. Now, here we are using only chloride. So, that is the power of your oxygen. Let us see the oxides. What are oxides? Binary compounds of oxygen with other elements are called as oxides. For example, we all know carbon dioxide, nitrogen dioxide, sulfur dioxide, whatever. So these so many oxides are there around us. Oxides basically are of 4 types if you talk about their pH. So acidic, basic, neutral and amphoteric. Acidic oxides are those which when mixed with water generate acids. Basic oxides are those which when mixed with water generate a base. Neutral oxides are those which do not generate an acid or a base, they remain as a neutral, they are resistant to your blue litmus, red litmus, they don't turn the color of the litmus. Amphoteric oxides are those which can behave like an acid as well as a base. If they behave like an acid, they will react with base, and vice versa. That means if they behave like a base, they will react with an acid. Examples, yes, you have to learn these examples. We have here, like acidic oxides are formed by non-metals, basic oxides are formed by metals, neutral oxides and amphoteric oxides are found by your p block elements. Okay, like carbon monoxide is there, nitric oxide is there. Let's look at this reaction now. This is important for your exam. This is important for your exam. Now here we can see that alumina, that is Al2O3, is dissolving in hydrochloric acid to give you a complex H2O6 3 plus. So you can see that alumina dissolves in HCl to form a soluble complex. Alumina dissolves in sodium hydroxide to form a sodium complex, soluble complex. So your complex means a species which will be written inside the square bracket. Next compound is ozone. About this compound we will study in the next class.